Hello and welcome to our lesson on composition of functions. This is going to be from section 9.1 in our text. Let's jump right in. First of all, with an O'Neill description of what composition of functions is. In my understanding, or at least in my head, I think of composition of functions like a turducken. Now, if you know what a turducken is, that's a boneless chicken stuffed into a boneless duck, and then that stuffed into a boneless turkey. So just like there, you're stuffing a bird into a bird into a bird, composition of function is kind of like that in that you're stuffing a function into another function and then sometimes even into a third function. Okay? So just think of composition of functions as function stuffing. Let's get down to the examples. First of all, we have f of x given to us. The function f of x here is 3x plus 1. We also have function g of x given to us. This is a quadratic function, x squared minus 2x minus 6. And for the first example, they're going to want us to find f circle g of negative 1. Now, the circle can be read as composition. So you can either say f composition g of negative 1, or you can say f circle g of negative 1, or you could even say f of g of negative 1. What you can't say is fog. This is not fog. This is f circle g, f of g, or f composition g. Any of those are okay. How does this work? Well, the first thing we're going to do is we're going to get rid of this circle and we're going to rewrite this problem using nested parentheses. So this is going to be f of g of negative 1. Got that? The first thing you do to do a composition with a function value is you rewrite it using nested parentheses and then plug and play from the inside out. So we're going to start on the inside, and negative 1 is going to plug into g. Now, what is that going to look like? Well, that's going to be f of, and then if I go to g of x and replace every x with negative 1, that's going to be negative 1 squared minus 2 times negative 1 minus 6. And then I need to work all of that out. Now, what I'm going to do to work that out is I'm going to use my calculator. And so we're going to say parentheses, negative 1 squared minus 2 times negative 1 minus 6. And that works out to be negative 3. So all of this stuff in the parentheses simplifies to negative 3. Okay, and then what we're going to do is we're going to take the negative 3 and plug it into f. And what is that going to look like? Well, now if I go to f of x, which is 3x plus 1, and I replace the x with negative 3, that's going to be 3 times negative 3 plus 1. And then I need to work that out. 3 times negative 3, negative 9 plus 1 is negative 8. Isn't that great? That's the answer. That's the answer for the original problem of f circle g of negative 1. Now, to summarize what happened, we took the negative 1 and plugged it into g, and then the answer from that plugs into f. Number 5. Here we have g circle f of 5. Again, or you could say g of f of 5. And the first thing we're going to do is we're going to rewrite this problem using nested parentheses. That's going to be g of f of 5. And then plug and play from the inside out. So here the first step is to plug 5 into f. Go into f of x. We're going to have g of 3 times 5 plus 1. And then we need to work that out. Okay, 3 times 5, that's 15 plus 1 is 16. And so now we need to calculate g of 16. And what that means, it means now we're going to plug 16 into g, replacing every x with 16. That's going to be 16 squared minus 2 times 16 minus 6. And then again, to calculate all of that mess, I'm going to use the calculator. And I'm going to cheat a little bit. I'm going to scroll back, delete, and 16. So that's going to be 16 squared, delete, and 16. Minus 2 times 16 minus 6, 218. And then 218 is the answer. That is the answer to the original problem, g of f of 5. And I do think it's important to point out that the order that the f and the g come in, that is definitely important. Okay, so did you notice the -1 plugged into g first, but the 5 plugged into f first? So the order that those functions are in is definitely going to matter. And that's it for the two examples that we're going to look at where we evaluate the composition of functions. Now for our next example, number 19, here we're given two new functions, a new f of x and a new g of x. Number 19 wants us to find f of g of x. Notice this time we do not have a value to plug in, so this is going to be function composition with just the functions. Now the first step is the same as before. The first step says you're going to rewrite using nested parentheses and then plug and play from the inside out. Now the most inside piece this time is g of x. So that's going to be f of g of x, which is 3x squared minus 2x minus 1. And now what we're going to do is plug all of this stuff into f, into his x. Got that? This trinomial is going to take the place of the x in f of x. Now, what is that going to look like? Well, that's going to be 3x squared minus 2x minus 1, all of that in place of x, and then plus 1. And then we'll need to simplify. So that's going to be 3x squared minus 2x. The -1 and plus 1 cancel, and we're done. So this answer is the answer for the composition f circle g of x. Also for number 19, they ask us to find the domain of the composition. They want the domain of the function. So in order to find the domain, we're going to ask ourselves, was there any restriction on g of x? And then is there any restriction on the composition? So g of x was a quadratic which has no restrictions. Polynomial functions have a domain of all real numbers. There's no restrictions. And then this answer is also a polynomial. So the domain in interval notation would be everything from minus infinity to infinity. This is the set of all real numbers because there are no restrictions on g of x or the composition. Number 19 also asks us to find G circle f of x. They want us to do the composition backwards. So if we rewrite using nested parentheses, that's going to be G of f of x, and then we're going to plug and play from the inside out. So the inside stuff is f of x, which is x plus 1. And the next step would be we're going to take this stuff and stuff it into G. Okay, so going to G of x, every x is going to get replaced with x plus 1. And what is that going to look like? Well, that's going to be 3 times x plus 1 squared minus 2 times x plus 1 minus 1. And now to simplify this function, we're going to have to do the FOIL method. So we're going to have 3 times x plus 1 times itself. Anything squared means times itself. The negative 2 is going to distribute, and the minus 1 comes down. All right, now let's F it up. Let's FOIL it. First, x times x gives me x squared. On the outside, 1 times x is x. On the inside, again, 1 times x is x. Last but not least, 1 times 1 is 1. And then minus 2x comes down, and I'm going to go ahead and combine like terms at the back. Next step, we're going to combine like terms in the parentheses. So we're going to have x squared plus 2x plus 1 minus 2x minus 3. And then we're going to use the distributive property. And that's going to give us 3x squared plus 6x plus 3 minus 2x minus 3. And then CLT one more time. CLT, combine like terms. I've got a 3x squared. I've got a plus 6x and a minus 2x. 6 minus 2 is 4x. And then look at this. Plus 3 minus 3 cancel completely. And I'm done. There's my answer for G circle f of x. Now, they also want the domain here. And again, the domain is going to depend on if f of x has a restriction, and then if the entire answer has a restriction. So if we go back and look at f of x was linear. This is y equals mx plus b form. This is linear. And a line that has a slope, as long as it's not a vertical line, it's going to be all real numbers for the domain. There's no restriction for a linear function unless it's a vertical line. And then there's no restriction for a polynomial, so this is not going to have a restriction. So again, the domain is going to be all real numbers, minus infinity to infinity for this problem. All right, for our last example in this lesson, number 27, again, here we're given new functions, a new f of x and a new g of x, and 27 asks to find f circle g of x and then state the domain of the composition. So to do f circle g of x, the first thing we're going to do is we're going to rewrite using nested parentheses and then plug and play from the inside out. So the most inside piece is g of x. So we're going to replace g of x with what it's equal to. And then we're going to take this stuff and stuff it into f. into f of x. Everywhere there's an x, we're going to replace it with square root of x. And that's going to be 2 square root of x plus 1. Again, if you see what happened, the x gets replaced with square root of x. And that's done. That is the composition. Now, let's talk domain. The domain is going to be all real numbers unless there's a restriction. Unless g of x has a restriction or the entire composition has a restriction. If we look at g of x, we can see that g of x is a square root function, and the composition also has just a square root in it. Okay, it's got the 2 square root of x plus 1, but the key feature here is square root of x. So the question is, are there any restrictions for a square root function? And the answer is definitely yes, because you can't square root any number. There are some numbers that you can't take the square root of. What are they? Well, they're negatives. You can't square root negative numbers. So for the restriction of a square root function, the radicand, which is the x this time, the radicand has to be greater than or equal to 0. That's the restriction on a square root function. And then since x is already solved for, then this tells us the values that x can be. X can only be numbers that are greater than or equal to 0. So then how does that domain look in interval notation? Well, if it's greater than or equal to 0, then it's going to be everything from 0 to infinity. And we use a bracket because that means 0 is included. So there is your domain in interval notation. If you were wondering what would the domain look like in set notation, it would be even easier than that. Once you've got your restriction, you basically have the set notation. That would be the set of all x such that, and then you write down the restriction. So there is your domain in set notation. Interval notation, set notation. Okay, not that you have to write both of them, but I'm showing you both in case you need it. Now, number 27 also asks us to find G circle f of x and to give the domain. So the first thing we're going to do is we're going to rewrite using nested parentheses and then plug and play from the inside out. And so f of x is the most inside piece. So we're going to replace f of x with 2x plus 1. And then we're going to take this stuff and stuff it into G. Every x in G of x gets replaced with 2x plus 1. And so that will be square root of 2x plus 1. Now, do you see how these answers are different? The f circle G of x answer and the G circle f of x answer. They are definitely going to be different. Okay, not always. Sometimes if you do the composition forward and backwards, you get the same answer, and that means something special that I'm not ready to go into in this lesson. Most of the time, they're going to produce different outcomes. And that means that we're going to have a different domain for G circle F. So f of x was linear, which means f of x didn't have a restriction. But the composition answer has a square root, and so that's going to have a restriction. And so the domain is not going to be all real numbers. If we look at the composition, remember just a second ago I said that the restriction says if you have a square root, the radicand has to be greater than or equal to 0. So here the restriction is 2x plus 1 has to be greater than or equal to 0. And we're going to need to solve that for x to find out what x has to be. Moving the plus 1 over, that's going to give me 2x greater than or equal to negative 1. Then if I divide both sides by 2, x has to be greater than or equal to negative 1/2. Now that is not the domain. That's the restriction. If you want the domain, you're going to have to write that in either interval notation or set notation. So let's do the domain in interval notation first. If x has to be greater than or equal to negative 1/2, then that means everything from negative 1/2, including negative 1/2, to infinity. That's going to be your domain in interval notation. And remember I said that the set notation is even easier than that. Once you have your restriction here, the set notation is just going to be the set of all x such that, and then you write the restriction. Got it? Interval notation, set notation, be prepared to give either answer. And I believe that covers pretty much everything you need to see for composition of functions. So, if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.